This group has chosen the real-time stock market monitoring app. The requirements for this application is it should do live price feeds, portfolio tracking, be able to send alerts. Users should be able to look up their profile information, past trading history, as well as just look up information on any particular stock of a symbol that they choose.
Hello, my name is Divyang and welcome to our group project submission video of course number CST8916 Remote Data and Real-Time Application. In this midterm project, we have selected option number 3, Real-Time Stock Market and Monitoring App. The main reason behind selecting this option was that here we can get to understand how the real application like Yahoo or other stock market application are working, and get to know about in more detail about REST and GraphQL and WebSockets. So this is our group project submission. In this group project, I have written my section 1, the comparison of REST and GraphQL. So here I have explained everything how a stock application is working. If it is using a REST or if it is using a GraphQL. Like whenever, like if we assume like there is an application like a yahoo.com, and whenever a customer just buy a stock, then what is the process behind the backend here? So how it works? So let's assume that it works on REST. So how REST work? So REST have fixed endpoints, like it gives like it works like it works on HTTP method. It works like HTTP method, which will be like get, post, put, delete. Every request has been done by a specific command like get or put. Like for example, if a customer he wants to buy something and he will buy a stock of Apple, then the REST API will be working, that it will provide all the information related to the stock, whatever he has asked. All the information will be provided to the customer. Similarly, if he asks for something else, then also all the information will be provided by the REST API. But there is one drawback, like REST Pro gives lots of other information also. Like if we ask for just a stock market price, we will also get to know about stock market current price, what was the price it was before, and lots of other information also. But on the other hand, GraphQL is totally different. It's not like that. It works on query language. When a customer make a request for only for the stock market stock price, then he will get in a result only stock price only, nothing else, no any extra information. So one of the drawback of GraphQL is that the customer have to learn about query languages, and it is little bit harder to run to operate it very easily. It's a little bit harder, but it makes our application run faster because it not continuously keep asking for the updates. Whenever customer ask for the updates, then only it will provide that update only, nothing extra information. But on the other side, REST is continuously asking for the request. It is continuously asking for the request or information, so it makes our application a little bit slower. But GraphQL makes our application faster. Yeah, and this is my part for section 1. It will be forward. It will be then Todd will be going to explain further. Thank you.
So my name's Todd. I'm going to be talking about the role of WebSockets in this particular application. WebSockets specifically for this application that we're working on basically plays the role of live stock feed information. WebSockets were the perfect choice for this because they allow the server to push updates instantly to clients over a persistent kind of bidirectional connection. Unlike choosing something like HTTP polling, where the client would repeatedly just probe the server at like static intervals for information. WebSockets keep that single persistent connection open, which allows two-way communication between the client and the server instantaneously as messages and kind of events come through. Clients will connect to the WebSocket server by initiating an HTTP handshake or a WebSocket upgrade. Should the server support WebSockets, that connection or that handshake request would be accepted. The client would then acknowledge that, and then that bidirectional communication would then keep open until one of either the server or the client closed that connection. This is very important for something like a stock trading app because stock prices can change rapidly, multiple times per minute. So something like HTTP polling, a trader could potentially miss a window if they're looking for a certain price target if that information isn't coming in real time. For instance, if you had HTTP polling for like say 15 seconds, it would probe the server every 15 seconds. Well, that price could change in that 15-second window, which would be devastating for somebody who's trying to, maybe sell their position for profit. Maybe they're up and they need to sell it and they hit a threshold at a certain price. Well, if you're not using WebSocket connections, you could miss that window and then your trade just would never execute, which would be absolutely devastating. WebSockets are also useful for tracking the stock portfolios in this particular instance. You might have several symbols all at once that you might be tracking as part of your portfolio, and maybe you have alerts being set up so that if the grand sum of all of your stocks maybe drop below a certain point, it'll send you an instant alert saying like, hey, you've dropped 6% or whatever percentage, and that will allow you to either adjust your position or keep an eye on it, or at least just you would know that, hey, here there's an issue or there's a potential issue with what's going on in the markets, because that data would be calculated as it comes in to the WebSockets. Overall, WebSockets are great for the real-time communication. They provide low latency. It's a great event-driven communication, and data packets being sent through WebSockets are headerless, so they're much more efficient at traveling between the server and the client. Thank you.
Good morning, everyone. My name is Hesheng. I'm going to walk through our architecture. The client, the top one, may use web application or mobile application to use our systems. The communication between our system and the client is go through by security HTTPS. And all of the income traffic will go through a API gateway and a load balancer. This layer can be implemented by Azure API management. From there, all requests are rotated to main service. The REST API will handle the transactional operations like user login, place order, and update on the information. This service runs on Azure Web Service. And the data will be stored into the Azure SQL database. For the real-time update, we designed to use a WebSockets server. It maintains a persistent connection and the instance push socket price. From behind, if a message broker such as the Azure Event Hubs can enable the event-driven communication, so that all the market information, market data from the external publisher will go through a broker processed by backend service, and then forecasting client. So generally speaking, this architecture ensures the scalability, latest availability, and make sure the trade can go through very well.